I'm going to try and do a live demo. This is one of our workflows that is for server-side ad insertion. Create custom abstractions for your cloud infrastructure. I'm just going to run a CDK deploy, and that actually applies those changes. Let's check on our deployment.
Looking forward to it.
Yeah, should be good. Hey, hello everyone. My name's James Mullan. I'm a Specialist Solutions Architect for AWS, and I'm really excited to talk to you about CDK and media services. Hopefully you've heard of CDK and maybe some media services too. So what I want to cover today is, generally how you build media services using AWS today. I'm going to do a little bit of a recap of infrastructure as code, and then we'll jump straight into CDK deploy, or say CDK in general, and kind of what the benefits are of CDK, and then hopefully wrap it round with how does it actually relate to media services, how we use CDK with our media services, and how you can get started. So I'm going to try and do a live demo, and let's see how that goes. But for those of you that haven't seen any AWS media services before, this is one of our workflows that is for server-side ad insertion. So we have products such as, or services such as Media Live, that is our cloud encoding. That's doing the transcoding in this case. We've got Media Package, which is our origination software or service, and that does things like just-in-time packaging, and also if you want to add DRM to your live streams, etc., you can do that all in Media Package. We then have Media Tailor. That is our personalization and monetization service. So that's where you can do your dynamic ad insertion, and we'll show you a little bit of that depending on where the Scutty markers fall in the screen. And then we've got our CloudFront, which is our CDN. We're going to use I know it's on the slide at the moment, but we aren't going to deploy an ad decision service as well. We're gonna risk it with just what we got. So if I jump, bit of feedback. If I jump over to it's going to be really weird because I need to turn around. So can you see that at the back, or do you want me to make it bigger? So just for a quick walkthrough. So this is actually a reference architecture that I'll show you later on. But this is where we're creating our CDK code, so our actual infrastructure for resources. And in this circumstance, we've got a media package construct, we've got a media live construct, a media tailor, and CloudFront, exactly what I just described. And there's a couple of key commands that you can use to work with CDK on the command line. So the first one I'm going to show you is CDK diff. And what that essentially does is I'm assumed on my CLI to my AWS account. And just to preview, I'm actually going to deploy it. This is all the changes that it's going to make. So you can see quite a few resources. And then for the time being, I'm just going to run a CDK deploy, and that actually applies those changes and creates them. The last thing is to just quickly do that so that it accepts the IAM changes. So we'll come back to that later on, hopefully, and we'll see what that looks like actually inside an account. So, like I said, I just wanted to touch on general infrastructure as code, and where we've come from and where we've gone with it to get to CDK. So let me just get back this up. So it all started with manual deployments. We used to follow wikis and playbooks, and sometimes those wikis and playbooks were out of date or details were missing. Anyone remember what we used to do in those days? We tried to find the last person to run it and really hoped that they went on holiday or they actually worked for the company. That was kind of the only thing that we could do. We then moved into kind of scripting, and that was actually building stuff in scripts, in this case Bash, and that kind of worked for a little bit of time, but it got very complicated very quickly because Bash was never really designed to be a deployment framework. The only advice that we could offer here was it worked last time, don't touch it. the next the step was a really important step in terms of infrastructure provisioning engines, and that was the introduction of using CloudFormation in a declarative language. So developers or an infrastructure team would be able to use a declarative language such as JSON or YAML and build those as templates. Another great point to this is we also got a lot of things handled for us with CloudFormation. So that would do all of our state management, it would do all our rollbacks if we needed to. You could do drift detection, and ultimately you've got a lot of error management out of the box there. We then had generators, and that was basically we write some code and we'll generate these YAML or JSON files. And then on top of this idea, we had tools such as CDK emerge, and that provided a set of tools and a framework for doing to create custom abstractions for your cloud infrastructure. But we'll go into detail a lot more about CDK in a bit. So, kind of comparing where we started, so the manual deployments, what actually made infrastructure as code great. Obviously, this is hopefully quite an obvious point, but the first point is, imagine you're doing 1,000 EC2 deployments by hand in the console, or with a bash script that you didn't know was actually going to work or it was going to exit halfway through. Yeah, not great. So with the introduction of templates and being able to use actual declarative language and engines, the amount of human errors that were actually introduced into these deployments were a lot less. And also humans take breaks, and that didn't help the situation either. The next great advantage in this is that the speed really increased too. So you could hit deploy on a CloudFormation script, or upload your template to AWS into CloudFormation, and obviously it'd be a lot quicker than somebody going through and doing it. I think it kind of reacts, or kind of when you think about it in a more complicated scenario where you're doing 1,000 EC2 deployments, but you've got to do it not just availability zone, but also cross-region. It really does impact that. The testability of templates is also an interesting one. So when you did things by hand, obviously you was following doc, there wasn't really anything to really check you or what you was doing. So tools such as CFLint, where you could do sanity checking on templates before it even went near your account, was also a great advantage. And then finally, this isn't a infrastructure as code benefit, but the CloudFormation engine, as I mentioned earlier, if you've got a more complex deployment to do and something did happen, you've got a lot more fallbacks such as the cloud or the rollbacks, etc. there. So CDK. So AWS Cloud Development Kit is an open source framework that allowed you to build it was an open source development framework that allowed you to model and provision your cloud applications infrastructures. So it was the part of that abstraction layer, and we'll talk a little bit more about abstraction in a while. But what CDK did was it synthesized to CloudFormation. That's a key concept to understand. So with CDK, you could also use familiar programming language. So the programming language we actually support down the side there. So you have Python, JavaScript, TypeScript, all those programming languages support. So you actually got a lot of things out of the box. So you could do linting, you could do your testing was easier because you had core accessible testing such as PyTest on Python or expectful assert on TypeScript. You could also use debugging, autocomplete, inline documentation, obviously a lot more. So as a developer, you didn't really have to go and read all the documentation like you used to. We provide a lot of the same defaults that get you up and working. And then obviously you can change these values as defaults later on as you grow to understand what you need to deploy into the cloud. So let's just quickly touch on CDK templates and what actually makes them better. The first one, I think, in my opinion, is that you've got a shared language. And what I mean by that is if you're a TypeScript house or a TypeScript company, you can write your application code and your infrastructure as code all in that one language. And I've got a nice story about this later on that I'll come back to. The other great advantage is that you could do a lot of, you could change how you did infrastructure as code and how you actually went through that review process. So you could take your CDK code and put it into your other development processes. So you could do merge requests or pull requests, etc. You could do testing. You could do code pairing, all those types of things. And obviously your linting and your formatting, etc., down to your company rules. With security and testability too, along with, obviously you can use CFN lint, but we actually got an introduction to things like CDK nag, and what that did was takes a set of rules, and you can run those rules against your CDK project, and that will allow you to understand if you've got any security vulnerabilities or you're not adhering to best practices. So you really close that developer feedback loop, so you understand those things up front before even having to deploy it to your account and obviously deploying it with those issues. And shared abstractions is another great one. So if you're a DevOps team and you had to control DNS, for example, so Route 53 is our AWS DNS service. If you wanted to not allow every single application team that you have to rewrite your Route 53 code, essentially, what you could do is create your own construct and library to basically serve that to your application teams. So that could do things like your hosted zone lookups or maybe even your DNS entries themselves. Just coming back to subject to your other development processes, I think another great thing about this, and I think it was on a previous slide, but one great thing about code and templates is that you can check them into your software versioning control software too. So we kind of moved to this place where you don't need to write additional documentation if you don't want to go alongside your infrastructure as code. Your code essentially becomes the documentation itself. That's a state in time of what your infrastructure looks like or will look like in a future deployment. And obviously, being in a repo or something like that, you get all your auditing quite easily. So you can see where things have been changed, who changed them, when they were changed, who reviewed it, all those things. And one thing about CDK is that it's based on something called the construct programming model. And what essentially we've done in AWS is we've isolated those base classes for CDK, and they are available as an open source project themselves, and they are actually available for third parties to come in and use them. And we then kind of move into a place where it literally is learn CDK once and write it everywhere. So we have third parties that have already integrated with this or using the construct programming model, such as CDK8, which is our Kubernetes using CDK. And then we've got CDK Terraform, which is CDK for Terraform. But any third party that is using a complex declarative language and wants to abstract can go in and use that construct programming model. Just quickly looking at the main components of CDK, we have the core framework, and the core framework is you have a CDK app and you have one or more stacks, and in these stacks you can have resources or your constructs. Now a stack in CDK is a one-to-one mapping with the CloudFormation stack that you see in the console today. We now have, we also have the AWS construct library, and that is something that we'll touch on looking at what the different layers mean. But it's a way of looking at the library and seeing what we have and using that as your kind of first port of call. And then finally, we've got AWS CDK CLI. And you saw a little bit at the start when I started looking at CDK diff and CDK deploy. And this is a tool that you can use to initialize CDK apps on your local machine. And it also obviously helps you deploy to AWS. So I've mentioned abstraction quite a lot. And what I wanted to just clarify is what the different construct levels are and how they are basically differ from each other. So layer 1 is automatically generated from CloudFormation resources. If you've seen CDK before or used CDK before, in the documentation these are normally prefixed with CFN something. These are automatically generated, and when a new CloudFormation release gets pulled in and CDK updates, they'll automatically be reflected in CDK. We typically think of layer 1 as your unpaved resources, i.e. you've got to, there's no real autocomplete. You know, if you've done a CloudFormation template before, everything that you have as required as default is the same here. Now layer 2 is where we take our layer 1 resources and we create AWS constructs from them. And what that means is that we set some same defaults as I mentioned earlier, but it also allows developers to get up and going with CDK quicker. I think the best way of thinking about these is your paved resources. So that's the difference there. And then finally, we've got the layer 3 plus purpose-built constructs, and these are your opinionated abstractions. Now these can be developed in two different ways. You could have your own personal company abstractions, so things that you know that you need to do every single time, and you want to build your own abstractions because you want to control it in one place. But equally, these could be community-led, so in the open source community. So I think like the best example here would be your Fargate load balanced service. Yeah. So how does CDK actually relate to media services today? So for media services, we are currently at layer 1, which means we are on that unpaved resource level. Our current support is across Media Connect, Media Convert, Media Live, Media Package, Media Store, and Media Tailor. Obviously, everything that you see in CloudFormation today. Now, it's kind of an interesting one. When it comes to layer 2, the open source community might build something. But if you think about layer 3 and how you want to use AWS Media Services in your company, there's nothing stopping you taking the layer 1 resources that we have today and building your own abstractions, so you can do whatever you need to do. So hopefully, let's check on our deployment and see what's going on there. So, sorry, I'll turn around. So what we have here is a successful deployment, which is great. What I am going to do, 2 seconds. So here is my AWS account that I've currently deployed to. So just to prove it actually deployed, this is our Media Service Reference Architecture SSAI workload. So as you can see, 7:30, I didn't lie, it actually worked. So what have we got in this architecture in particular? So they're all the things that I mentioned before. So if we go to Media Live and go to channels, we can see that we've got one channel running, and you can see that we've got the preview of that now. Now on this sample, we have CloudFormation outputs. So what we can do is go back to the stack itself and look at what we currently have available. And as you can see, we've got different options on the distribution. What we want to open up though is this example website. So that is actually the stream running. So what we set up was a Media Live instance with a running HLS input. We then did some origination here. So we've got media package running and we've got HLS and dash variants. We then have media tailor, as I mentioned, and that is the thing doing the manifest manipulation. So when a SCSI35 marker comes through on a stream, we hopefully will see a new ad, but I can't remember where they are on the stream. So we might have to just keep an eye out for it. And then we've got CloudFront, which is ultimately serving it. I'll come back to this in a minute. So, like I said, it kind of reflecting back on where we came from and where we are with the CDK, and I think this is equally as relevant for infrastructure as code. Our deployment time for this was about 15 minutes while we were just talking. So a massive improvement with doing things manually or through bash scripts that may or may not work. So just to recap, so we did a CDK deploy. It did some creates from the CLI. We then saw that it completed successfully. We saw the CloudFormation stack did actually exist. We saw some running on Media Live, and then we finally saw a stream running on our demo website. So how do you get started with CDK? I think there's 3 routes that you might want to take today. The first one is looking at the CDK documentation. That is actually a great place to get started because it will tell you all about CDK, how to initialize it, how to install a demo project or a skeleton project, so you can actually see how CDK projects are meant to look like. Secondly, we have a open source sample projects that we've been working on with some of the solutions architects in the EMEA region, and these are reference architectures that we wanted to build using CDK so that anyone can go in and start deploying these to demo and test accounts as soon as they can. From what's actually in there today, so that SSAI one that I've just deployed is part of that repo. We also have things like live to VOD using media package with a REST API also created in that sample. We also have how to build sustainable outputs on Media Live, so making sure that you're sharing codes across multiple outputs instead of creating an additional encode per an output. And then finally, we recently just launched a new one, which is also goes along with a new feature that we launched. So the thumbnails that I showed you as part of the Media Live input, it's a sample to take that feature and actually put it into more of an operations focused way. So it compares the input from Media Live and also an output from Media Live so that you can actually compare them side by side across multiple pipelines. And then finally, this is kind of new news, but we are doing a builder session or a workshop at reInvent this year. And that is going to be how to build CDK video workflows using CDK, along with how to do the deployments in services such as code pipeline and code build. So in a lot more of a more automated fashion. And then we're going to chuck in new things such as how do you take a live workflow and introduce SSAI, for example, or how do you introduce another solution that we currently have available today called secure media delivery at the edge, so tokenization at the edge, and how you revoke tokens there. we're going to hopefully build in some extension tasks around live to VOD and observability too, and maybe a bit of CMCD if we can get to it. So, thank you very much. Hopefully it was useful and interesting. If you have any feedback for me, I'd be glad to read them afterwards. But yeah, thank you very much.
Thank you. Do we have any questions for Jamie on that?
So the open source nature of what you have, I'm assuming this only works on AWS. So it's open source in the sense that we can use it, but we can only use it on AWS.
I'm talking about media services.
Well, CloudFormation and your CDK.
Yeah, I was aiming it more towards AWS CDK,
Right.
as
Okay.
opposed to
So there's no cross-platform kind of support in there.
not on. Like I said, where it's a learn once, write everywhere. You can
Right here.
use like things like the CDK8s project, because it's once you understand CDK and how it works, you'll understand how to write CDK.
Right. But it's a homegrown tool for
AWS CDK deployments, yes.
To watch more of these episodes, press subscribe on YouTube now.
Don't go anywhere, please, because we've got Patrick and James from MNC coming up with their talk right here.
I think it's interesting to be able to kind of describe and articulate that kind of process from going from manual deployments over to CDK and then reflecting on it from a media services perspective. So, yeah, it was good. Preston's right.